Welcome back to the second part of AC circuits with complex numbers. So we're moving on to example 3. We are given the formula V equals IZ, which is the AC circuit version of Ohm's law. They're giving us the current and they're giving us the impedance, and we're being asked to find the voltage. So we're going to simply put in the parts that we know. V is going to equal I 4 minus 3J. We're supposed to multiply that by our impedance, which is 8 minus 15J. So I have a binomial times a binomial, so I'm going to do each with each. 4 times 8 is 32. 4 times minus 15 is negative 60. Negative 3J times 8 is negative 24J. Negative 3J times negative 15 is a positive 45J squared. I'll go ahead and combine those, giving myself 32. 6 minus 84J plus 45. The J squared is actually negative 1. So I'm going to go ahead and multiply that. So I get 32 minus 84J minus 45. So my final answer is whatever 32 minus 45, which is negative 13 minus 84J. And of course, voltage is in volts. So in example 4, it's the same formula, but we're being asked to find a different part. And I didn't write these in because I couldn't find in the equation writer, I couldn't write how to do it. So I'm actually given that V equals 7, 36.3 degrees. And that's volts, and our current is 2.5 at 12.6 amps, and so then I need to find out what my Z or my impedance is. I'm sorry, my reactance. And so Z in this case, if I'm trying to get Z by itself, actually I'm going to go ahead and do that real quick just to show you instead of just jumping at it. If we do V equals IZ and I want Z by itself, I would divide by I. That would get Z by itself. So Z is equal to V divided by I. V is 7 over 37 at 36.3 degrees. I is 2.5 at 12.6 degrees. So my answer is going to be 7 divided by 2.5, 36.3 minus 12.6. So when I go ahead and do the math, I end up with approximately 2.8 at 23.7 degrees. Okay, so the last one that we're going to do is multiple parts. So the big picture is that we're trying to find the impedance and the phase angle. And we can't find the impedance because we don't know the reactance, and we don't know the inductive reactance or the capacitive reactance, but we do have all the parts. So it's just going to take us a little bit to get to where we're trying to go. So the first thing we're going to have to do is find this inductive reactance. So inductive reactance is XL. And in the beginning we talked about XL was 2 pi FL. And you can go back and refer to the beginning of the notes. So 2 times pi, F is our frequency, which is 60. So times 60, times our L, which is 0.2 henries. So 2 times 60 times 0.2 is 24 pi ohms. And I'm going to go ahead and just leave it like that for a minute. Now, if I was going ahead and needed to know what that was, just for reference, it is 75.4 ohms approximately. Now that wasn't too bad. Let's go ahead and find the capacitive reactance. So that is XC. XC, if we went back to the beginning, is 1 over 2 pi FC. So 2 pi, F is still 60. Now, C, notice, is 40. This is microfarads. And so you have to look up what micro means, and anywhere that you look, it's going to tell you that it is 10 to the negative 6. So the micro, what we're going to do is we're going to go 40 times 10 to the negative 6. Because I can't have it in microfarads, I need it in just straight farads. If that would have been a different symbol, whatever that symbol would have related to, that's what I would have put here. And so I'm going to go ahead and put all this into my calculator. And I end up with 1 divided by 0.0048 pi ohms, which is approximately 66.3. So I found A and I found B. So now I can get to what I was actually trying to find. This is what I would be wanting to do if I was really doing this. So what I really wanted to know is what's the impedance? So impedance is Z. So if we think back to the formulas, it told us that Z is R plus J times X. But I don't know X, but I do know that I have XL minus XC, which was the second part of the equation. So it would be R, which I just found. Actually, I didn't find it. They gave it to me, so I'm not sure why I'm writing the symbol. Let's put in what it is. So it tells us R is 38 plus J. XL is 75.4 approximately. XC is approximately 66.3. So I end up with 38 plus 9 point, that would be 1, depending on where you're rounding, J. Now, if I'm actually looking for the impedance, it's the magnitude, and so this is not our answer. This is our X, and this is our Y, and so I actually have to plug this into my magnitude formula, which remember was the square root, 38 squared plus 9.1 squared. And I end up with approximately 39.1 ohms. So that is my impedance. The last piece is to find the phase angle, which is the difference between the current and the voltage. The phase angle is the inverse tangent of y over x, so that's 9.1 over 38, which gives me an approximate angle of 13.4 degrees. So those are all of the different parts that you would actually need to be finding in order to find the impedance and the phase angle. Okay, with that, that completes chapter 14. So you will have a test. In fact, you did have a test, so please, if you need to go back and finish the test or to redo any parts, please do so, and then I can go from there. Have a good day.